Here at Station 7, we're trying to remember how to solve for one variable like n, x, y, etc. To do that, you want to be sure you use your inverses or opposites to rearrange things. You'll remember that we talked about how plus and minus are opposites of each other, or multiply and divide are also inverses. When you do this, you want to follow PEMDAS when you're simplifying one side and then reverse it to get a variable by itself. If you're working with an inequality, the most important thing to remember is that you must flip the inequality symbol if you multiply or divide by a negative. What I mean by that is if it's less than and you multiply both sides by a negative, you're going to make it greater than. If it's greater than or equal to and you multiply by a negative, you're going to make it less than or equal to. So you're going to flip the inequality if you multiply or divide by a negative. The last thing I want to remind you of is to be careful when you're distributing a negative. You don't want to fall in the trap that most of us do, such as if I'm multiplying negative 2 times x minus 1, most of us are very good at saying negative 2 times x is negative 2x. But then when we do negative 2 times negative 1, we forget that both of these have a negative, and a negative times a negative makes a positive, so that becomes positive 2. Let's look at a few examples to help you. You'll remember when we started that what we would do is draw a line down the equal sign or the inequality sign, and then check for distribution and like terms on each side. On this first side, I don't see anything that needs to be distributed, and I don't see any like terms. On the right, same thing, no distribution, no like terms. So my next step was to move all the variables to the left. What I'm saying is I want to move the variable 3n, the whole term, from the right side to the left side. Because it's positive, the only way to move it is to subtract. So I'm going to subtract 3n from both sides. You'll notice and remember that I lined up variables with variables so that these would be like terms. 3n and negative 3n makes a zero pair, which means that they cancel. And over here on the left, I have 2n minus 3n, which is negative n. I'm going to bring down that 3, and I'm going to bring down my negative 4. After we would move the variables to the left, we would try to move the numbers to the right. I want to move positive 3 over here to the right side. The opposite of positive is negative. So I'm going to subtract 3 from both sides. And again, I'm going to make a total bar, reminding myself that I've created a zero pair. I'm going to bring down that negative n. And don't forget to bring down the negative. That's a mistake I see a lot of students make. They forget about that negative. Then I've got negative 4 and negative 3. So that makes negative 7. And I've almost got this solved, except I have a negative in front of n, so n is still not solved or isolated by itself. To get rid of a negative, I can either multiply by negative 1 or divide by negative 1. So I'm going to do that. I'm going to divide both sides by negative 1 to get rid of this negative. I'm left with n over here on the left, and a negative 7 divided negative 1 makes positive 7. And because I did that thing that I have to remember, I divided by a negative, I need to flip my inequality. It's no longer less than, it's now greater than. And I've got my solution. Let's say that on test day you forget that. One way that you could test your solution to make sure that it's right on a multiple choice test is to pick something for n that's greater than 7. For example, if I say, well, I want my n to equal 8, then I can take my original problem and I can plug in 8. Of course, I would suggest that you use your calculator here just for speed. But if you did, 2 times 8 is 16 plus 3, that's 19. And on this side, 3 times 8 is 24, minus 4 is 20. You can quickly check, is 19 less than 20? Well, yes, it is. So I know that this answer is also correct. Again, if you forgot, you could test all of your solutions to see which one would work. Okay, let's move on to another example. What if I said solve for x when y is less than or equal to negative 4 times x minus 12 plus 5 when y is equal to 10? You might say, well, that's a lot of information. First thing is I want x by itself. That's my end goal. If I have a highlighter, this may be a good time to just highlight that x so I won't forget what my goal is here. The problem also tells me when y equals 10. That means y always equals 10 in this scenario. So I'm going to put 10 in place of y. And then I'm going to copy down the rest of the problem. And I'm trying to isolate my x. So I need to follow my steps. I see distribution over here on the right. So I'm going to distribute negative 4 times x, Negative 4 times negative 12. Again, watch that double negative. That's a major problem spot for people. And then I'm going to carry down my 5. I see that I have some like terms here. So everything else stays exactly the same. And 48 plus 5 is 53. Now I want to get x by itself. Right now it's over here on the right, and that's completely fine. I'm going to leave it there, although you could go a different direction. I'm going to go ahead and move my numbers to the left. Looks like it'll be fewer steps this time. So I'm going to subtract 53 from both sides. 10 minus 53 is negative 43, is less than or equal to negative 4x. Now all I have to do is get rid of that negative 4. So I'm going to divide both sides by negative 4 because the inverse of multiply is divide. And negative 43 divided by negative 4, if I do that in my calculator, you'll see negative 43 divided by negative 4 is 10.75. And that's kind of gross. My teacher does not like decimals. So I'm going to change it back to a fraction, and it just turns out to be 43 over 4. I divided by a negative, so I've got to be sure that I flip my inequality. One other thing I want to tell you here. Again, multiple choice may look different than your answer. For instance, this could look like this. The x could be on the left side, meaning I would also flip my inequality and my solution. This is more likely the answer you're going to see. But what if they give it to you as a decimal or a mixed number? Do you know what is equivalent? Well, in this case, what if I was given 10 and 3/4? Hopefully you know that that's the same as 10.75 because 10 is the whole number and 0.75, like 75 cents, is 3/4 of a dollar. If you weren't sure, you could always type in 10 and then a fraction. And I guess I haven't mastered how to get it to do a mixed number, so I have to do a little adjusting. But 10 and 3/4, and you can see that it's also 43/4. So a couple ways to write that answer. Any of these are equivalent and fine. It's just a matter of what is the multiple choice going to look like. The last thing that I want to talk to you about at this station is literal equations. Literal equations just means a formula. Basically very little or no numbers, only variables. Your goal, again, is to get the variable by itself. Everything else you treat just like numbers. So if it's being multiplied, the inverse is to divide. If it's being added, the inverse is to subtract. Use a highlighter to help you keep your focus. For example, if this equation asks me to solve for w, I'm going to highlight w because that's my goal. And then I want to ask myself the question, what is happening to keep w from being by itself? Well, it's being multiplied by L and H. So the inverse of multiply by L and H is divide by L and H. And we know that when I do something to one side, I also do it to the other. I've canceled out my L and my H, and so now W equals V over L times H. W is by itself, and so I'm done.